All over the world, bee populations are decreasing. It's a worrying trend because bees are the most important pollinators of many wildflowers and agricultural crops. Disease may be causing some colonies to collapse, but recent research shows that chemicals in pesticides are also harming honeybees, and this is backed up by a new study on bumblebees at London's Royal Holloway University.
Work in my lab is building on previous work looking at neonicotinoids, the systemic pesticides that are used extensively in agriculture at the moment. And what we're doing is we're looking at the effects of multiple pesticides, not just the neonicotinoids but also pyrethroids, which is the sort of situation that bees are faced with in the field. They visit multiple crop species which may have different pesticides applied to them.
The bees were exposed to low levels of these pesticides for 4 weeks. They lived in small colonies in the lab, but they were able to go outside via a long tube connected to the window. This allowed them to collect pollen from real flowers, as they would in the wild, while Richard kept a close eye on their foraging behaviour.
The bees all have an individual ID radio frequency identification tag stuck to their backs. Each one of those comes with an unambiguous number, a unique ID. Each time a bee leaves the colony, it's registered by a particular reader, an RFID reader. When the bee comes back, again it gets read by the same readers, and we can tell the identification of each and every bee that goes out and comes back, and we know the exact time that they've spent outside in the environment.
Well, what we found is that this sort of chronic exposure, this long-term exposure to low levels of pesticide is affecting the behaviour of individual bees and therefore the performance of colonies. So we're seeing that link. And those that were exposed to both pesticides consistently performed the most poorly in all of our measures. But the most interesting findings perhaps are that the neonicotinoid imidacloprid affected foraging performance of workers. So the ones that the colonies that were treated with that pesticide actually sent out more foragers, but those foragers were much less effective at bringing back pollen, which is a limiting factor for colony growth.
It's certainly concerning that having these combination of pesticides outside could be causing such a severe impact. But we know we've only looked at 2 pesticides, yet we know that there are hundreds of pesticides used out there. Millions of areas of agricultural land are being sprayed with these pesticides, and these bees are being exposed to them.
Currently, pesticides are actually regulated very tightly, but the focus is very much on what are the lethal effects, so what dosages will kill bees, and particularly honeybees are the focus of those tests. What I think our study shows is that longer-term effects of lower doses can also be important. So they may be relatively subtle effects on behaviour, but there are effects on the individual bees which filter up to the colony level and can have effects on whether colonies actually thrive or even fail.
You do get a sort of personal feel with them, and especially when you're seeing them get affected so badly by these pesticides, you're thinking what really is going on in the wild, and you know, are they really being affected this badly?
For me, it is vital. I mean, bees are fascinating creatures. They're massively important in the ecosystem, so we can't lose them.